Hey, this is Dr. B, and in this lab we're going to determine the concentration of an unknown silver nitrate solution. This is the chemcollective, and it's a virtual lab. Let's have a look. For the following problem, we'll consider the reaction of sodium chloride with silver nitrate to make sodium nitrate and silver chloride. And in a way, they're giving it away, at least from my perspective, because they're telling you what reaction to perform in order to see how much silver nitrate is in there. In other words, it dissolves in water. Sodium chloride dissolves in water, so it's hard to see what's in there. But when you mix the two together, it forms silver chloride, which precipitates out. Now, that doesn't tell you directly how much silver nitrate was there, but you can back calculate how much you must have started with. Of course, in the real world, you'd have to collect it, dry it, etc. But this is a virtual lab, so things will be a little bit different. It says the solution labeled Solution 3 in the virtual lab stockroom has an unknown amount of silver nitrate. Design and perform an experiment to determine the mass of silver nitrate that was present in Solution 3 solution. Now, honestly, you could spend a lot of time playing around with these things and trying to do what makes sense to you. Like maybe you're going to first prepare a fixed molarity sodium chloride solution, add an excess of it to the silver nitrate solution, wet that precipitate form, and then collect it by vacuum filtration. You'll find that there is no vacuum filtration apparatus. There is something that says remove solid, but that's a different matter. However, after playing around with this thing for a while, here's what I came up with. We're going to take that unknown silver nitrate solution. We're going to take some sodium chloride. We're going to put it on top of it and pour it directly in. Now, in the real world, you'd have to put it into a balance first, but when you do this, it can tell you how much to put in. And it's okay in this unrealistic world to put an excess in. I'm going to put 100 grams in. Now imagine what would happen, and watch. So it says, okay, 100 grams has been transferred. Wonderful. Now in the real world, that would be a big mistake because sure, you'd get a precipitate of sodium chloride, but you'd also have some of your excess sodium chloride that precipitated, and you would just have a big white powder that you're collecting. That would not be very helpful. But it works in this particular case, and it looks like we collected directly. We don't have to vacuum filter or anything. We've got about 2.37 grams of silver chloride. So can we write that we had 2.37 grams of silver nitrate present? No, it turns out that silver nitrate, from which it was derived in a 1-to-1 ratio that you saw up at the top, see how one of these produces one of those, is a little bit heavier. The silver chloride is, let's see, 1.18, no, the silver nitrate is 1.185 times heavier. So in essence, you'll be multiplying that by 1.185. I created a little PowerPoint that should try to clear that up a little bit. So your goal was to find out how much silver nitrate was in the solution. We're going to add excess sodium chloride, collect it, and back calculate how much sodium nitrate formed for every molecule of sodium nitrate. This should be Ag, should it not? Ag. For every molecule of silver chloride that formed, it came from one molecule of silver nitrate, so that's wonderful. Since silver nitrate weighs a little bit more than silver chloride, that would be our multiplying factor, which is 1.1852. And that would be the fastest way to calculate it. That's typically not the way they teach it, however. They do a long analysis like this. So say if you started with, let's see, 10 grams of silver chloride that was formed for every 140, that would be 10 over 143 in terms of mole, and for every mole of silver chloride, you form a mole of silver nitrate, and for every mole of silver nitrate, it weighs that much. Take a look at that and convince yourself that's the same thing as just multiplying it by 1.185, right? And so that's what I'm going to do when I go back here. I'm going to go back to the lab, and it says it formed 2.36779. I guess I'll use all of those numbers. Clear. So I'll do 2.36779 times my multiplying factor 1.1852, and I get 2.3 0.806 grams. Now I think I will use, I see 5 sig figs, 5 sig figs. I see a lot of sig figs here. And is there anything that's limiting it? Gee, I don't know. I'm just going to say 2.81 grams. Let's see what it says. 2.81 grams. Oops, that's not supposed to go there. 2.81 grams. Let's check it. And it says, experiment part done. Well done, you did a good job. And there you go. Let's just for practice, we could enter different amounts and you'd see that each of them are different. Anyhow, I hope that this helps you with this lab. And there you go.